Welcome to the fourth episode of The Gist of It. Today we'll be summarizing a talk called Why Open Source Firmware is Important by Jessie Frazelle, which belongs to the GOTO conference in Chicago 2019.
Exactly. And we chose this topic, as also Jessie points out in the beginning of the talk, since it's something that is way less talked about in, computer science, systems engineering, compared to many other talks. Specifically at these conferences, you have quite high-level programming topics usually, and not so many lower-level stuff closer to the hardware. So that's why we chose this, and this is also why Jessie held a talk about it. Yes. Nicely for us, she, I gotta say, she separated the talk into three parts, which are about security, usability, and visibility of firmware within hardware. So I guess let's kick it right off with the security part.
So she explains the different rings in which the architecture is organized, and these rings have a number. From 3 to 0, but then there's also negative rings.
Yes, maybe we should quickly explain for those of you who never heard of these rings what they do. So they're the protection rings, and it's pretty easy. It just means that the higher the number is, the less privileges they have. So if you think about your kernel, for example, it's in this model 0, which means that it's not too close to the hardware, but pretty close to the hardware, meaning that it has a lot of privileges. So it can operate and just execute whatever it wants. And then on top of this is like drivers. And for example, the last thing is just your user software, which has the least privileges, which is generally speaking 3. But as Nuria said, there's also negative levels. What do they do?
Basically this... There's 3 negative levels, which are under the kernel of the computer.
Which means they have even more privileges than the kernel.
And the -1 is a hypervisor, which we can at least know what it does or see.
Depends what processor it is, but indeed, in most or oftentimes nowadays, there's Xen being used. Which is open source. So you if you want to, little people will do that, but it is open source, so you could look at it.
Yes, but the other 2, you cannot really access it or know exactly what those 2 levels are doing, and they are also the ones with more privileges. So that's a bit
counterintuitive.
Yeah, exactly.
So namely, these are the UEFI or EFI kernel, which does essentially that your computer can boot, and SSM, which is power management, but also proprietary features of your processor. And then finally, which she mainly focuses about, the management engine. So generally speaking, this talk is focused on Intel processors. It's similar but different, of course, on AMD or completely different architectures by other vendors. And the management engine essentially is like the lowest part, the closest to the hardware, which does management stuff. So it can update itself like other firmware. It has its own network stack. It does a lot of things, but is essentially managing the core processor features. But it's also software at the end of the day, so it's not hardware, of course. Then one point she makes there, which is quite interesting, is that some years ago, I think 2 years before this talk was held, researchers found out that Minix is shipped in this, or is part of this management engine of Intel. For those of you who don't know, Minix is a Unix distribution, pretty old one, like late 80s, I believe, which is a lightweight Unix that was made by Andrew Tannenbaum to teach his students how Unix works and should look like. And Intel just picked it up since it's open source or even public domain, I believe, to include it in there to do some features so they don't have to code them themselves. Problem is it's like a fully fledged kernel and even operating system. So it has like a whole web server and a network stack and everything, which she makes a good point is a bit of a security risk since
And actually, she continues on explaining some hacks or security issues that happen due to all these firmware having many like parts that are not really necessary, like this web server that you just said.
Exactly. Another interesting thing that I'm not sure if you mentioned, but I find it very interesting. This also makes Minix, by the way, the most run kernel/operating system in the whole world, since just to the sheer amount of number of Intel servers processors that are being used by people. So it's the most used operating system, technically speaking. And the general point, I think, of this of this whole chapter is that, well, yeah, counterintuitively, the lower the ring is, so the higher the privileges, the less we know about it. So possibly we don't have this effect of open source that many people can look at it, meaning that, well, it's less likely that bugs are being found, since, well, the code is not known.
And all of this software has exploits that you cannot know about because you cannot access it, you don't control it.
Exactly. And also she mentions a couple of, we won't go into too much detail now, of course, because it's a summary. She mentions a couple of bugs and follow-up exploits of them in the past. And the big problem with this, compared to many other vulnerabilities, is that you can technically, with this, target every single person that runs this, like an Intel processor, or at least one that is vulnerable, which makes this a very nice target, generally speaking, because you can target millions and trillions even of people, compared to more focused hacks, let's say.
I would say let's go to the second point of view.
Yes. Yeah. One last thing I would want to mention is that one big security issue that she mentions is that the management engine of Intel has the possibility to, even while the computer is powered off, so it needs, of course, power like on the main board, but not turned on. It can even modify itself and other firmwares and keep the state for subsequent boots, which of course is a huge possible problem if someone manages to find a vulnerability, flash their own shit on there, and then the user, even while the computer is completely turned off, gets like some malware firmware injected. On the other hand, I wonder, there's a bit of a double-edged sword, I think, because Intel also used this to update their firmware, which had like bugs. So if they completely disallow these updates, well, they can never patch them. So I'm not too sure if it is a double-edged sword, let's say. Yeah, Indeed. Let's move on to the usability part.
Yes. For the usability part, well, it's the shortest part of the talk.
It's like 1 minute.
Yes. She bases it on a questionnaire that she published, in which she was asking some questions to people that own data centers.
She asked them essentially, a couple of questions, and then the main point of the survey was to ask them what the pain points for them are in using their servers. And she didn't specifically ask about it, but in the end, 29% of the participants said that firmware is a pain point of them.
Basically, her point is that people that have to use it think that it is painful to use or manage.
Yes.
So the whole thing is that it's not really usable if people that use it have problems.
Exactly. So if you agree, then let's just directly move on to visibility, since that was exactly the whole usability part, which was a bit sad, but okay. Yes, here her first point is, again, which she kind of made already earlier, is but is a very good one, is that counterintuitively, which we said earlier already, the higher the privileges, generally the less visible the software is. So the lower tier levels, and specifically the management engine, are completely closed source, so no one knows exactly what's going on there. Of course, Minix is accessible, but we also don't know what modifications they made to it and so on. So yeah.
Yes. Well, basically, this whole point of view is around this idea of the Conway's law, which is that when a company or an organization does or designs a piece of software
or a system in general,
this design is based on or influenced by how the company is organized itself. So which teams are there? How do these teams communicate?
Yeah. So to give an example, if you have, 10 teams, it is likely just going to happen that you'll end up with roughly 10 like subsystem in your system, because these teams work closely together and then they have maybe interface towards each other.
Her point is that the entire software ecosystem, let's say, it's organized based on how developers are organized and how developers communicate.
Yes, and she makes a point that of these bugs that were detected in the past, many happened because the subsystems of like the processor, for example, had some vulnerabilities like toward each other. So if you found like using one subsystem, you could influence another one, for example, and then cause a vulnerability, which you could then use to inject some malware, for example. Which she makes the point mainly happens since these, or hypothesizes, not makes the point, it mainly happens since these teams developing the subsystems of this whole processor software, didn't communicate enough, or not cross-check enough, or didn't test enough in the whole thing. And essentially the higher level picture is missing. Like they are very good at developing their own parts, but then everything as a whole thing, the higher level, it's a bit problematic. Another point why this might happen is also that it's too complex.
She also explains that if you find a bug and you are debugging it, trying to find why the cause of it, and you find out that it's not your specific fault, but you have to talk to a vendor.
For example, if you own a data center, she comes back to the survey. Yeah.
It's very likely that even this vendor is not really can't fix the bug itself, but it's consulting another vendor, and the communication here is not really working, right?
Yes. And she generally says that debugging gets super difficult because until you hit this management engine or even the rings above it, you can debug everything pretty nicely and look into the source code and everything. But when you hit that and essentially eliminated that the problem is yours, you just hit rock bottom because you cannot do much more, which is pretty shit to develop a nice system. I think that's mainly it for the visibility part.
Yes. Let's go to the conclusion, solution of the situation.
Yes. As one guessed already from the title of the talk, her solution that she proposes is to make firmware open source. Here she brings one thing that is, I think, like pushed and developed by Facebook and Google, if I remember correctly, which is NERF, which stands for Non-Extensible Reduced Firmware, which is like a concept really, how to make open source firmware generally aim for making the firmware less capable of doing harm in whatever way that might be. So make it harder for it to inject malware and stuff like this.
Basically doing something simple that only does what it has to do.
Yes, which would alleviate this problem with the visibility she made, that one of the reasons why this in the first place is so like bugs may be introduced is because it's so overly complex that no one can have like a higher level understanding of it, and which forces the like people to only look at a certain part, and then everything working together has some vulnerability. So reducing the complexity and making it minimal also alleviates this problem. Another one that she mentions is to remove the capability that they can reflash themselves, where here, I'm not too sure if this is completely possible, since you can still introduce bugs, of course, and then you kind of have to reflash. So it's a good point, but I'm not sure how feasible it is. And then the way how to do this is that she proposes, or which is also part of other people out of this firmware space, and they propose to just use Linux a lot more in this. Mm-hmm. And for example, to just combine the UEFI and SMM, so power management stuff, into just like a light Linux kernel, which is already super battle tested. I mean, it's used everywhere, which would allow to make this a lot more visible, more secure. All the points she made pretty much, and also more usable. And then the other point that she makes is this would also allow for more higher level languages to be able to use for the firmware, since if they can run on Linux kernel, then you could use them, yes. Which has a few nice points.
Yes, basically, if you can develop firmware in a more higher level, it means that it's more accessible for more developers to both develop and
Review it.
Exactly.
Then, like the point she always makes is Go, which is also pushed by Google. I guess that's one of the reasons why it's part of this NERF project. And the other reason there she makes is that with Go specifically, or other languages that have this feature, you could also make it more memory safe. So if you have like a language like Go, where with the compiled to machine code, the compiled code, you can already have memory safety. You later, when it's running, have a lot less problems or none with memory allocation failures or stuff like this, which of course in C and assembly are super easy to introduce, and it doesn't guard against anything.
So basically, if you can develop it in a more higher level, you lose or can avoid some of the problems of low level, basically.
Exactly. And then the final point she makes is that it might sound like you will lose some speed due to using higher level languages, due to using like Linux kernel and stuff. She sadly doesn't mention where she got that from, but she says that in tests, in air quotes, people found that the boot times are increased 20-fold when using this NERF architecture. And then her very, very final point is essentially her statement, so to say, is, well, to make this better, you should make it open source, which does three things. It increases visibility, it minimizes the whole complexity, and it improves the communication between developers, since open source community is already pretty established and the communication is working pretty well already. So that can continue also for firmware, which it sadly doesn't yet, compared to many other parts of the computer. Then what's your verdict?
I think it was a very nice talk, and I for sure recommend it to watch it, because I mean she also explained some other stuff that we didn't talk about, obviously, and she's a very good speaker.
Yeah, it's fun to listen to her. Like she's so like the comedic aspect is a bit pronounced.
Yes. So, and it's also very interesting, and you don't really need a lot of knowledge about the topic to understand the talk perfectly fine.
Yeah, I agree. I liked it. I gotta say, she's a pretty good public speaker, and it was fun listening to her. The only thing that I found a bit sad is that she didn't use the survey more, because she mentioned that 400 people participated in, which is like quite solid sampling size. And I would have liked, if she makes like the point, okay, 29% said this firmware is a pain point for them, to use a bit more. Why did they say that? What exactly are their pain points? And also in the other parts, she could have, if you ask me, made more use of it. So since she went through the effort to even do this, she didn't use it very much. And this usability part was kind of useless.
Yeah.
So yeah.
I mean, she made her point, but it's true that it was a bit short and not very developed, let's say.
Yeah. I think that's a very good final verdict and summary. So I think there's nothing more to add. Then thank you very much for listening. As always, if you like this episode, recommend it to friends and colleagues. And you can find us on our website, gist.fm. And that's it.
Yes, you have, as always, as well, the link to the talk. And see you in the next episode.
Bye-bye.